Hey everybody, let's look at one more problem where we find the domain of a composition where we're looking at H composed with G composed with f of x. And if you haven't found this type of triple composition before, go ahead and take a moment to get your answer and hit pause and so you can try it. And so here is our work when we do it. Again, when I do these problems, I like to just take my time, write the inside function, take that inside function, plug it into the next function, take that function, and plug it into our final one. And so this is what we end up with. And so when we find the domain of the composition of functions, what we want to do is start with the inside function and see if there's any restrictions on that. When that's plugged into the next function, we want to make sure that look for any like funny, interesting, look for any parts where it can like screw up the domain. And so here we have another radical, and then in fact G composed of x, which we already found the domain for in the previous video. And then now we're just taking this answer, plugging it into H. So now we're concerned about when the denominator is equal to 0 because we have that rational function. So let's summarize all that information on the next page. Again, so we have our composed function here. The domain of f, which was the x squared minus 4x, is all real numbers. The domain of G composed of f was the answer that we found in the previous video, which was -infinity to -1 union 3 to infinity. And so now we want to find the domain of H composed with G composed with f. And so that's when we were saying we were going to solve this denominator equal to 0. Again, to solve this, we have a radical equation, and we'll want to isolate the radical. I'm going to go ahead and add the square root of x squared minus 4x plus 3 to both sides. We'll have this. To get rid of the radical, we square both sides. And I'm left with 9 equals x squared minus 4x plus 3. This is the quadratic equation, so it's always helpful to get this equal 0. So I'm going to subtract 9 to both sides. And I'll be left with x squared minus 4x. What was it again? Minusing 9, 3 minus 9, -6 is going to equal 0. Now I wonder, will this factor? No. You can use the quadratic formula, but I think in this case I'm going to complete the square. We'll start by adding the 6 back over, and then taking the -4, dividing it by 2, and squaring it. And then when I add 4 to the left side, I need to add 4 to the right side. This now allows me to factor as a perfect square trinomial, x minus 2 squared equals 10. I'm going to square root both sides to get rid of the square. So I'll have x minus 2 equals, don't forget, plus or minus square root 10. Then add 2 to both sides. And so we're going to at least have 2 real answers. We might as well plug these into our calculators. So when we look at 2 plus square root 10, that's approximately 5.16. And 2 minus square root 10 is approximately -1.16. All right, so putting all the pieces together, if we look back, we know that the domain of f is all real numbers. But then we're taking that number line and we have to chop it up into two parts, the negative infinity to negative 1, and then the 3 to infinity. And we've just now realized that we have to exclude these two numbers as well. And so what the domain for h of g of f is, it's going to be our negative infinity to, okay, so we know that negative 1.16 is going to be smaller. So this will be 2 minus square root 10, parenthesis, because we do not want to include that number, union, 2 minus square root 10 to negative 1, union, 3 to 2 plus square root 10, parenthesis, union, 2 plus square root 10 to infinity. Ha! Couldn't fit it on the page. And this is our answer. This problem is not like going to be on a test or your homework, or it could be a good homework problem, but it's not going to be a good test problem just because it takes a lot of time. There's a lot of steps, but I hope it does give you a chance to see like the process and the way that we have to find the domain of the composition, and also it illustrates a lot of different techniques to solving various equations. All right, I hope you found this helpful, and I'll see you in another video.